Right now, in a stretch of the Pacific Ocean most people will never see, sea surface temperatures have been sitting at record highs for more than a month straight. And meteorologists tracking that data are watching it edge toward a number reached only once before in recorded history. On August the 3rd, NOAA's Climate Prediction Center confirmed that El Niño is not just present, but actively strengthening across the central and eastern equatorial Pacific, with an 81% chance of reaching very strong conditions between October and December, and a 97% chance of persisting through the start of next spring. While most of the world spent June and July focused on the heat waves breaking records over their own heads, in Europe, in Asia, across the southern United States, here is what almost nobody was connecting to that heat in real time: the ocean engine. Actually, driving a huge share of this year's extreme weather has been quietly outpacing nearly every forecast written for it, and scientists studying it are now openly comparing it to events that reshaped the global climate for a full year afterward. This is the story of how strong this El Niño has actually become, why researchers keep reaching for historical comparisons most have never had to use in their own careers, and what it means for the rest of this year and into the next. No hype, no exaggeration, just what the NOAA, World Meteorological Organization, and peer-reviewed forecast data actually shows. If your region has felt unusually extreme weather this summer, drop a comment and tell me what it looked like, because there is a real chance El Niño is part of the reason. I read every one of these. If you want grounded climate coverage built on the actual data instead of recycled panic, subscribe. It is free. And A-like helps this reach people who need to understand this before winter arrives. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. To understand why scientists are reacting this strongly, you first need to understand what El Niño actually is, because it is not a storm or a single weather event. It is a shift in the ocean itself. Under normal conditions, trade winds blow steadily from east to west across the tropical Pacific, piling warm surface water up near Asia and Australia, while allowing cooler water to rise along the coast of South America. El Niño happens when those trade winds weaken or reverse, letting that warm water slosh back east across the Pacific instead, raising sea surface temperatures across a massive stretch of ocean, and changing how much heat and moisture gets pumped into the atmosphere above it. That shift does not stay contained to the ocean. It physically moves the jet stream, alters where storm tracks form, and reshapes rainfall and temperature patterns on nearly every continent, which is exactly why a warming patch of water near the equator can end up connected to a heat dome over Europe, or a monsoon shortfall in India months later. Scientists measure the strength of an event using the Oceanic Niño Index, and more recently a refined version called the Relative Oceanic Niño Index, which adjusts for the fact that the entire ocean has been steadily warming for decades and would otherwise make every new event look artificially stronger than it really is. Once that index crosses 1.5 degrees Celsius above average, NOAA classifies the event as strong. Past 2 degrees, it becomes very strong. Colloquially, a super El Niño, a threshold reached only 3 times in the modern satellite record in 1982, 1997, and 2015. This is where the current numbers become genuinely striking rather than routine. The Niño 3.4 region, the stretch of Central Pacific scientists watch most closely, saw its temperature anomaly climb from 0.5 degree Celsius above average in April to just under 1 degree in May to 1.6 degrees by June, according to NOAA's Climate Prediction Center, an unusually steep and fast climb by historical standards. Meteorologist Ben Knoll has tracked those sea surface temperatures, sitting at record highs, for a full month, closing in on the 40-day streak set during the historic 1997 event, one of only 3 super El Niños on record. Climate data analyst Zeke Housefather's independent review of the forecast ensembles found that no prior year in the 45-year satellite record has been running this warm, this early, not 1997, not 2015, with the current multi-model consensus giving roughly a 91% chance FA record peak using the standard index and 77%, even using the more conservative warming-adjusted version. Nat Johnson, a meteorologist at NOAA's Geophysical Fluid Dynamics Laboratory, described his reaction to the earliest version of this forecast back in March plainly, saying only 1997 was comparable, and that he knew immediately something unusual was building. What makes this event different from those historical comparisons is not just its potential strength, it is the world it is forming inside of. And that context is the second major reason scientists are treating this so seriously. Every previous super El Niño on record, in 1982, 1997, and 2015, developed against a cooler global baseline than the one we are living in now. Global temperatures are already running, roughly 1.4 degrees Celsius above pre-industrial levels before El Niño's own warming effect is added on top. Daniel Swain, a climate scientist who tracks California and Western weather extensively, put it directly, saying the world has never experienced a strong or very strong El Niño layered onto pre-existing global conditions this warm. That distinction matters because it means the historical playbook for what a super El Niño typically does, based on 1982, 1997, and 2015, may not accurately predict what this one produces, since it is unfolding on top of an ocean and atmosphere that already hold more stored heat than during any of those three prior events. The practical consequences of that combination are already visible in places most people were not watching this summer. India's monsoon rainfall came in roughly 20% below its long-term average through mid-July. A shortfall meteorologists link directly to the same weakening trade wind pattern driving El Niño's development. The Atlantic hurricane season has had its slowest start since 2009, with NOAA and Colorado State University both sharply lowering their storm forecasts for the remainder of the year. Because the same El Niño-driven wind shear that disrupts monsoon patterns also tends to tear apart developing Atlantic storms before they can organize. Compounding the picture further, the World Meteorological Organization is also tracking a positive Indian Ocean dipole developing alongside this El Niño, a separate but related ocean pattern that tends to amplify drought risk in some regions and flooding risk in others across the entire Indian Ocean basin, meaning two reinforcing climate drivers are now active at once rather than one. It would be inaccurate and irresponsible to treat a strong El Niño forecast as a guarantee of catastrophe, and the scientists closest to this data are explicit about that distinction. Michel Leroux, a physical scientist on NOAA's own El Niño forecasting team, has been direct that stronger events do not guarantee stronger impacts everywhere. They only make certain regional impacts more likely, and the exact pattern of who gets drought and who gets flooding can still shift from one event to the next, even at similar strength. The 2015 to 2016 Super El Niño, for example, did not deliver the wetter than average winter Southern California typically expects. What forecasters can say with much higher confidence is the direction of risk by region rather than a precise outcome in any single location, and that regional picture is genuinely serious. A European Union Joint Research Center analysis published in June specifically flagged East Africa, Central Africa, the Central American dry corridor spanning El Salvador, Guatemala, Honduras, and Nicaragua, and parts of South and Southeast Asia as regions where this event will layer additional drought and food insecurity risk onto populations already dealing with displacement and conflict. There is also an economic dimension to this story that rarely gets attention until the bill comes due, and it is worth stating plainly. A 2023 study published in the journal Science calculated that the 1982 to 1983 Super El Niño cost the global economy an estimated $4.1 trillion in lost income. And the 1997 to 1998 event, the strongest on record at the time, cost an estimated $5.7 trillion, largely through disrupted agriculture, damaged infrastructure, and reduced labor productivity across multiple continents that took years rather than months to recover from. That same 1997 to 1998 event caused torrential flooding and a subsequent Rift Valley fever outbreak in East Africa, drought-driven wildfires across Southeast Asia, and catastrophic flooding and landslides in California, while bleaching roughly 16% of the world's coral reefs. Marine ecologist Danielle Clare has described coral as the literal foundation of an entire reef ecosystem, meaning a strong bleaching event does not just damage one species, it can unravel the fisheries, tourism revenue, and coastal storm protection that millions of people in developing coastal nations depend on for their livelihoods. Behind these percentages and index thresholds is a version of daily life already shifting for people who have never heard the term Relative Oceanic Niño Index. It is a rice farmer in the Philippines, watching a monsoon season arrive weaker and later than it should. It is a family in Guatemala's dry corridor facing a second consecutive difficult harvest layered on top of existing food insecurity. It is a fisher off a Pacific island nation whose catch has already started shifting as warmer water pushes fish populations toward cooler depths. None of these are hypothetical outcomes waiting on a future forecast. They are the early regional fingerprints of a global ocean pattern still months away from its projected peak. So what does all of this actually mean for you, regardless of where you live? It means the extreme heat and unusual weather many regions experienced this summer very likely was not a standalone event. It was one visible symptom of an ocean pattern still actively strengthening and not expected to peak until sometime between October and January. If you live somewhere, El Niño typically brings wetter conditions, the southern United States, parts of South America. That means watching for an unusually active wet season ahead. If you live somewhere, it typically brings drought, Southeast Asia, Australia, parts of Southern Africa, and Central America. That means the water and food security planning conversations happening now are Genuinely worth taking seriously rather than dismissing as premature. And if you are simply trying to understand why this year has felt unusually extreme across seemingly unconnected parts of the world, the honest answer is that a significant share of it traces back to the same warming patch of ocean water this video just walked through. The honest, grounded summary of this story is this. NOAA confirmed on August the 3rd that El Niño is present and actively strengthening across the central and eastern Pacific, with an 81% chance of reaching very strong or super El Niño status by year's end. An independent analysis of the forecast data gives roughly a 91% chance this event sets a new record in the primary index scientists use to measure EET. What makes this event scientifically significant is not simply its potential strength, comparable to the historic events of 1982, 1997, and 2015, but that it is developing on top of a global climate already 1.4 degrees Celsius warmer than pre-industrial. Levels, a combination the modern instrumental record has never previously captured. The consequences are already measurable. A below-average Indian monsoon, a historically quiet start to the Atlantic hurricane season, and a World Meteorological Organization warning that a second reinforcing ocean pattern, a positive Indian ocean dipole, is developing alongside it. Scientists are clear that strength does not guarantee identical impacts to past events, but the regional risk picture, concentrated heavily across East Africa, Central America, and South and Southeast Asia, is one researchers are treating with genuine urgency. We are going to keep tracking this event exactly the way we tracked it today, straight from NOAA, the World Meteorological Organization, and the researchers actually publishing this forecast data in real time, not recycled headlines dressed up as a new story. Subscribe so you do not miss how this event evolves toward its projected peak later this year, because based on everything the current data shows, this is very likely the beginning of the story rather than the middle of it. And leave that comment below. Tell me if the extreme weather you experienced this summer makes a little more sense knowing what was building underneath it, because the T connection is exactly the pattern this entire video has been explaining. 5,000 likes on this one. Let us go. See you in the next one.